Today, we're going to dive into a really fascinating and maybe even a little unsettling idea. The surprising biological link between reaching the absolute peak of physical performance and how long you might actually live.
You know, you see a champion athlete, someone at the very top of their game, and you think, wow, that's the picture of health, right? But what if there's a hidden cost to getting that gold medal? What if reaching that summit has a price?
And that's the big paradox we're looking at. The idea that pushing the human body to its absolute limit, achieving a level of strength and speed that seems almost superhuman, might actually involve a kind of trade-off against living a longer life.
So where does an idea like this even come from? Well, a huge piece of the puzzle comes from a pretty groundbreaking study from 2016 that looked at a very special group of athletes from a totally different time.
Researchers looked at over 1,000 track and field Olympians from the very early days of the modern games, from 1896 all the way to 1936. And what makes this group so perfect for a study like this is that they competed long before performance-enhancing drugs were a thing. This gives us a really clean look at just pure human biology. And the scientists had the key data, their personal bests, and, crucially, how old they were when they died. And what they found was, well, it was a bombshell. Before we even get into the numbers, you just have to look at what the researchers themselves said. This was the first time that this kind of trade-off, which scientists had seen in animals for years, was actually found in humans. It's a huge deal.
So what did they find? First up, it was all about timing. The athletes who hit their peak performance, their personal best, at a younger age, they actually had a 17% higher mortality rate than the athletes who peaked later in life. Peaking young and fast seemed to come with a real biological cost.
But wait, it wasn't just about when they peaked. It was also about how good they were. The most dominant athletes, the ones who were ranked way higher than everyone else, had an 11% increased mortality rate. So being the best of the best, that carried a price too.
Okay, so what does all this mean in real human terms? For the male athletes who checked both boxes, they peaked early and they were extraordinarily good. The cost was a staggering 4.7 years off their life. That's almost 5 years, seemingly traded for that moment of glory on the track. And this chart? Wow, it just lays it all out, doesn't it? You can see the average lifespan for the guys who peaked the youngest versus those who peaked the oldest. That gap is undeniable. It shows a pretty clear connection between peaking later and living longer.
The numbers are one thing, but they leave us with a massive question. Why? Why would this even happen? And the answer, it turns out, isn't really about sports. It's about a fundamental principle in biology called life history theory.
So what is life history theory? At its heart, it's all about how every living thing, from a tiny insect to us, manages its resources. See, every organism has a limited amount of energy to spend over its lifetime. So the big question is, how does it budget that energy for all the things it needs to do, like growing up, staying healthy, having kids, and eventually getting old?
The simplest way to think about it is this. Imagine you have a finite energy budget for your entire life. Every single bit of energy you spend on one thing, say growing taller or fighting off a cold, is energy you can't spend on something else. It's basically a biological zero-sum game. Now, this theory splits that budget into two main accounts. On one side, you have somatic effort. That's all the energy that goes into building and maintaining your own body. Growth, survival, long-term repairs. The other account is reproductive effort. And this isn't just about making babies. Biologically speaking, it also includes all the energy you spend on becoming physically powerful and dominant, which helps in competing. You could almost call it the show-off budget.
And this brings us right back to those Olympians. Pushing your body to achieve a world record performance, that's a massive investment in that reproductive effort side of the budget. It's a huge expenditure on physical dominance. And what life history theory predicts is that if you spend that much in one account, you have to be taking it from somewhere else. And that somewhere else is likely the somatic effort account, the one responsible for long-term maintenance and survival.
All right, let's pull all these threads together. We've got the shocking data, and we have the biological theory behind it, but what does this live fast effect really mean for those of us who aren't elite athletes?
You see, all of our lives follow a kind of biological strategy. We grow and develop, we reach maturity, and then we're constantly making these unconscious choices about how to split our energy between maintaining our bodies and other efforts. And the choices made early on, especially how fast and how hard we push during our peak years, can have these ripple effects that last all the way to the end.
Now, I have to stop and be absolutely 100% clear about something.
This is not, in any way, an argument against exercise. The health benefits of regular, consistent physical activity are completely proven and undisputed. What we're talking about here is totally different. We're talking about the absolute biological extremes of human performance.
What this whole study really does is give us a dramatic illustration of a basic rule of life. When you pour a truly massive amount of your body's energy budget into one single area, like achieving peak physical power, you might be borrowing those resources from another area, like the deep cellular repair systems that help you live a long, healthy life.
And you know, when you think about it, this isn't just about biology. It's kind of a metaphor for life, isn't it? We all have a finite budget of time and energy. And we're constantly making choices, right? Investing in our careers, our families, our passions, and it's always at the expense of something else. This research just shows that this rule goes all the way down to our very cells. So it leaves you with a question. Life is a series of trade-offs. What are yours?